Hello and welcome to the Messy Mondays podcast, episode number 2. Today I have with me Mr. Thomas Seubert. Hello, welcome. There is a lot of conversation about what is MES, what is SCADA, what is MOM, a lot of different terminologies. And I think you're the best person to talk to, trying to make a sense of all of this. Because to be very honest, I am also confused. I would like some help. So welcome.
It is a confusing area. I struggled with it for a while until I tried to figure out the way to organize it and take a look at it. And then that came with experience. So, Kunal, thank you for allowing me to join you today. I look forward to our conversation on MES. I think before we get started, let me go ahead and talk about my background. Back in 1990, I got my bachelor's degree in electrical engineering, and I started off as a controls engineer at manufacturing plants, mostly automotive. At the time, there was no such thing as Industry 4.0. We were doing Industry 3.0, and that was PLC and SCADA-based solutions. We were controlling and enunciating for specific workstations and work areas. There were no bachelor's degrees in manufacturing engineering at the time. That came around, probably started around accredited programs in the mid-90s. So that was a limitation there. And then also, as I went through my career, what I noticed is that what we now call Industry 4.0 was the inclusion of IT into the manufacturing environment, your servers, your networks, your clients, your PCs, and now even cloud-based solutions didn't really start occurring until the mid-90s. So we've actually been living in what we call Industry 4.0 for only about 20 years now. As my career progressed, I mentioned I was in automotive. I also did some aerospace. Automotive really deals with just-in-time, very tight deliverables and order structures and supply chain management. Aerospace deals mostly with traceability, which should surprise no one considering some of the news about the Boeing aircraft company in the past few months. I've done some work in steel and plastics, which was continuous manufacturing. I had a couple projects for pharmaceuticals and life sciences, and that one should surprise no one that is highly involved with traceability because a lot of that is legally regulated. Okay, I've done some food and beverage work in the past, which is also traceability and very highly specialized sanitary process and maintenance adherence. And currently I'm working in the electronics industry where we're not only building printed circuit boards, but also electronic assemblies.
So I talked about how to build your career in MES. I was talking to Matt about this. And what comes out to me from your experience is that you were able to pivot from one industry to another and two very unrelated industries also, like moving from aerospace to food and bev or pharma. How did you manage that?
That's a good question, and this is going to lead into something that we've talked about already. When I was going through my career, there was no standards within MES. You talk to 5 people, you would get 5 completely different answers to MES. And that really bothered me. And then what it was that as I was kind of going through the different industries, I noticed that there were some common themes within manufacturing, and then there's also obviously some differences. Well, those common themes led me to take a look to see what type of books that are out there with regards to MES. And with that, I found that a lot of MES books dealt with trying to deploy functionality either at the workstation or at the work area, which was still more of a SCADA type delivery. It really wasn't focusing on the overall processes within the plant to execute manufacturing. at that point, I realized that there's a lot of commonality between all of those that drove basically to, instead of taking the plant floor up approach, the book that I co-authored took a process top-down approach. And a lot of things cleared up as to saying, okay, most manufacturing has order, order scheduling and management. You got quality. Quality should always be not an afterthought in manufacturing, but a concurrent part of manufacturing. Material handling, which is the in-plant process of supply chain to make sure that the right part gets to the right station at the right time and in the right sequence. And then overarching all of that is an overall process production management, where we look at throughput, we look at equipment uptime, we look at production performance, we also look at first-time quality. All those three areas, equipment uptime, production, performance, and first-time quality, all make up that metric that a lot of people pay attention to, called OEE, overall equipment effectiveness. And then as you take a look at that, a lot of that is common between all the different manufacturing. Going back to quality, that's where we start getting into differences, because that's when you start talking about the traceability and the product-specific data models. So there's where some differences come in.
So I see that earlier it was, let's say you have only one use case, you want to see a dashboard on this machine, and you implement what is required for that particular use case. And then it sort of, went on to look at the bigger picture in terms of what problems are we solving in different functions, production, quality, maintenance, and look at it holistically, right?
Right.
So if I had to ask you, because I'm sure a lot of people have this question, how would you define MES in terms of not only what the components of MES are, but what does it actually do?
Okay.
Yeah.
MES is not a system. It's not a solution. It's not an IT product. MES are the processes that are used to ensure that you can execute your manufacturing. It will take your product information from PLM, product lifecycle management. It also will take into account your ERP information, your resources, your employees, your certifications, your supply chain information, so on and so forth. And it tries to manage and align all those together so that you can basically manufacture a product in a certain amount of time, within a managed amount of time, with high quality. So I mentioned the four main components of MES I mentioned already was order management. Are you building to order? Are you building to stock? How do you manage that? How do you make sure that you don't shortchange something if you're manufacturing something to a customer that's just in time? We talked about quality. Now, quality assurance is not only your quality testing, but also your built-in processes to make sure that, okay, if I have a choice of picking a specific part to go into this assembly, how do I make sure I pick the proper part? We get into barcode scanning on that typically. Work instructions. Work instructions are directly tied to the product. So for that workstation and for a specific product, here's that work instruction to make sure that that work is executed properly. Recipes and routings, very important, also part of quality assurance. But then there's also, your quality testing, where you might be doing some in-process testing and you might be doing some end product testing. Third thing is that I mentioned before, making sure that the right material gets delivered to the right workstation at the right time and in the right sequence. Automotive seating is an excellent example of that. How are you going to make sure, because those orders come in and they need to be delivered in a proper sequence? making sure that those seat covers, whether they're black cloth or gray leather, are scheduled and arriving at that workstation at the right time. That's an internal material handling and supply chain activity. And then just to make sure that the overall health and the real-time enunciation and trending of your whole production environment. We mentioned throughput, we mentioned OEE, we mentioned equipment uptime, monitoring equipment, throughput. It could come down to, okay, my production performance is low for this workstation. Well, you throw out that, okay, it's running low right now. Okay, it happens. Well, they investigate and they find out it's a new operator there who is not familiar with the operation and is taking a few more seconds to do the operation. Or it might be a piece of automated equipment where it's starting to wear down and it's taking longer for it to complete its cycle. And then once you aggregate all that data in together, you can do trending, you can do forecasting, you can do a little bit of predictability depending on the maturity of your algorithms. And then also, once you have that in place, introducing a new product into the manufacturing environment is that much easier because you have all of that in place already.
Yeah. So that is like encompassing almost all the functions once a product starts on your line, right? And it also heavily is influenced by and also influences the neighboring processes around it.
Right. And this would be a good time to talk about one of the misconceptions out there is that MES, Manufacturing Execution System, is the same as Manufacturing Operations Management, MOM. Hi, Mom. It isn't. When you think about what it takes to operate a manufacturing facility, it's not just all the real-time activities going on. You have other processes, including your product engineering, design, and lifecycle activities, your ERP activities. MES, ERP, and PLM all actually make up part of manufacturing operations management. So that's something that we have to be a little bit more clear on to understand, because there's more to manufacturing than just executing it. Within ERP is your planning. How do you make sure that your vendors are supplying the material that you're forecasting? That's not an MES function. How do you make sure that the product that you're manufacturing is meeting the goals and objectives and the operational constraints that it was designed for? That's actually coming out of PLM. And then how do you compare one manufacturing site to another manufacturing site when they're doing the same thing? That's also not MES. That's more of a MOM type operation. So there's a little bit more to this than some people might imagine at first.
So is it correct to say that all the supporting functions for your execution encompass manufacturing operations? Let's say a CRM does not support or influence your operations in any way directly. So that might not be a part of MOM. Is that correct to say?
Yes, that's actually a good point. When we start talking about MOM has sometimes direct or indirect influences outside of the manufacturing environment. Some of it is, the availability of the market right now. For example, right now you're not seeing a lot of people jumping onto the electric vehicle, the EV industry, because right now that market is really not that robust. Outside of that, as you mentioned, CRM, customer relationship management. That's how, when you manufacture a product for a specific customer, that's the processes and so on and so forth to make sure that the customer's happy and the customer's paying you. That's not necessarily manufacturing operations. Same thing that goes with supply chain. Typically, a manufacturer will get multiple vendors to supply material, but each one of those vendors also probably have multiple customers. Well, that type of handshaking and balancing and so on and so forth is happening outside of manufacturing operations.
Yeah, I think that clears the terminology up quite a bit. But then it brings me to the point that, why is this terminology important? I mean, how does it matter if I call MES something else and you call it something else?
It's like the difference between talking English and German.
Mm-hmm.
If you don't know the language, you don't know the terminology, it is very difficult to communicate effectively visions, goals, objectives, and what is actually clearly understood. If one thing we haven't talked about is the difference between MES and SCADA.
Mm-hmm.
And SCADA, if I mentioned it properly, I want to repeat it, is SCADA is actually more of an Industry 3.0 solution, PLC based, that dealt with specific workstations on the platform or work areas. For example, the transfer press that a lot of automotive companies use to stamp out their body panels, the doors, the fenders, the quarter panels, so on and so forth.
Mm-hmm.
Typically, that's one piece of equipment which has maybe 4 or 5 different stamp presses that are connected by a common conveyor. Now, each workstation can have a SCADA interface, user interface, as well as there's a SCADA interface for the whole transfer press line itself. So being able to understand what constitutes the difference between a SCADA and MES and what constitutes the difference between MES and MOM makes the conversation more efficient. It will make sure that people are speaking the same language so that it can be more clearly understood of what is being presented, what's being marketed, what are the goals and objectives. If someone's saying, well, I have a SCADA system that's that's taking care of a transfer press, MES does not necessarily need to be aware of the details of that, but should be aware of the throughput of the product or the parts that are going through that line.
So basically, there is a conversation going on around in terms of, if I am a manufacturer, you said that it is easier for me to buy a particular product. So when we talk about COTS products, I understand what you're saying. Mm-hmm. But what if I want to integrate my SAP with my shop floor? I want to see my production orders on my shop floor, and I want to get my material consumption back to SAP. I want to do my production booking back to SAP. Mm-hmm. I don't care whether I call it MES or anything. And I approach an implementation partner, and that person says, okay, we will do it for you. Do you see that approach also being taken in terms of, I have one problem and I just want the problem being solved?
The challenge there is it doesn't matter. Yeah, I mean, you mentioned SAP, so let's say we'll just say in generic ERP.
Yeah, any ERP, yeah.
I know that several ERP systems, including SAP, have already integrated and included certain MES features and functions.
Mm-hmm.
And since they already share a common data model in that area, that makes perfect sense. Okay. But if you take a look at the definition of the process that ERP covers and the process that MES covers, they're different processes. And that's, I think, where we have to be a little bit more careful to understand, and this is probably the key point of understanding manufacturing in general, is knowing the processes, understanding the processes, and then understanding what technology enabler you're using to enable those processes and to make it manageable, controllable. The humans can go in there and be able to use it. ERP is exactly that, enterprise resource planning. It's the scheduling. It's the employee certifications. It's all that gets the administrative and the framework for manufacturing to happen. But it's not responsible for the actual manufacturing itself. Again, it's really more of the administration that gets everything to the manufacturing plant. MES is supposed to take that framework and then also take the information that's provided by whatever PLM, product lifecycle management system they have, which is also a set of processes. It's product specific and brings those ERP and PLM aspects together so that it can manufacture a product with high quality and with the most efficient way of using the plant capacity.
Yeah.
There's always going to be a limit. Most automotive plants run 60 jobs an hour. That means one job, one vehicle is in one workstation for literally 60 seconds. That's tight.
Yeah.
They've tried to go faster. They have not always been successful because the capacity, there's a limit to that. And that's up to MES to be able to show that, to provide that information back. It can provide the feedback back to ERP to saying, this is how we're doing our orders fulfillment. This is how we're supplying the product to the customer, as well as going back and providing feedback to PLM to say, okay, yes, we were using these work instructions. And by the way, these were the lot numbers and all the different traceabilities that went into this product so that we can come back and trace it back later. It's kind of the melding between ERP and PLM.
So basically, like you said, right, the time granularity in terms of ERP is dealing with, let's say, you get your orders once a day or twice a day, maybe. But in your MES, let's say, take an example of automotive, your screens are, let's say, changing every minute. And now the point I see there is that MES or ERP, it is more than a software, but it is actually people and teams working together.
Absolutely.
So that logical separation is also to enable them to, work together, and so that their requirements are met in that particular software, right? It is not only mixing software, but also mixing functions, mixing ways of working and teams also.
Right.
Yeah.
On that, and I was going to touch upon this later, but I think now would be a good time, is one of the things that lead to a lot of confusion within MES is not just what's ERP, what's MES, what's PLM, but within MES, for like quality activities, there's separate quality software packages out there. And the reason for that is a lot of manufacturing plants have separate quality teams that their job is to manage and improve upon quality.
Yeah.
MES already has been defined as a process to handle that as well. So there's a little bit of confusion. Is it in MES? Is it in quality system? Is it somewhere in between? The answer is yes, it depends. So there's the interfaces between MES and quality. Another good example is there's some really excellent e-maintenance software packages out there that helps the maintenance team at the plant stay on top of and keep their equipment up and running as much as possible. That also kind of started as part of the real-time interface with MES. If the production critical equipment went down, you wanted to know about it immediately and dispatch someone over there immediately. Some MES has a little bit more defined materials and maintenance support. Others interface with an existing e-maintenance system to provide that. Again, it depends on the plant and how they're structured and what provides the best support for their processes. So maintenance could be in MES, maintenance could be in a separate system as well. So that there's that. It depends on the plant itself, the organization of the plant, how are they structured to do what they're trying to do to, again, put out the best product possible.
Yeah, so MES, let's say, as a set of functions is defined, and within those set of functions, you can have different softwares playing different parts, but the key part that you mentioned is that they should talk to each other. Right? You said about maintenance softwares, the context of the actual work order on the line will be given to it by the MES, let's say, something like that.
Something along those lines. Again, we don't want to get too far into that because each system is a little bit different. And understanding not only how the plant is operating, but also how the software operates and supports the plant is almost equally important. Do your homework. Okay. That's also another thing. One of the things that a lot of people who are coming into manufacturing may not fully realize and have a good feel for and appreciate is that ERP very quickly provided and proven their value add and the return on investment. Depending on the complexity of the product, PLM has done something similar. Unfortunately, MES has had a more storied history. A lot of projects that happened in the past occurred where the process and the system did not necessarily mesh up, and the system ended up either not fulfilling the requirements properly, or they added non-value added work to the operator. And it got to a point where a lot of those systems were abandoned because it just wasn't helping the manufacturer out. As well as manufacturing in certain areas, manufacturing is actually a very old thing. We're dealing with plants that are 10, 20, 30, 50 years old. Those plants have older equipment, but older processes, and they're in a situation where trying to introduce something new is more difficult because a lot of the development of MES has been siloed. Order management happened at one point. Quality assurance happened at another point. Production monitoring has kind of happened across the board, so that's probably not that much. The problem with those type of siloed approaches is that there's not a common data layer, and it's very difficult for these different IT systems to share data because their data models are different. Well, if we come in and say, okay, well, we can improve things by deploying this very common data model that will not only help your MES, but your ERP and your PLM. That is a significant implementation where you're basically tearing out an old system and putting in a new.
Yeah.
So for those reasons, there are reluctance in brownfield plants to deploy new systems. They've been hurt in the past. They don't have the time, nor the money, nor the resources to do a big implementation. So one of the approaches that we need to take into account is coming in, finding out what the manufacturer's pain points are. Is it equipment uptime? Is it trying to manage the orders? Is it trying to increase first-time quality? Are they having production throughput issues? Understanding their pain points and prioritizing the projects to improve those pain points, because that way you're providing, if done properly, value add for them with a very quick return on investment, ROI. Gone are the days of 18 plus months of ROI. That's not happening anymore. They're looking between 6 to 12 months ROI on a lot of these activities. But then on the other side, since I mentioned brownfield, we also have where you're coming into a brand new facility, a greenfield. There's nothing there. There's not even a process there yet. Historically speaking, when we talk about that, waterfall engineering for that usually would take 2 years. You define the process, then you define your hardware, then define the software, and you do a very methodical approach. That's lengthy. That can take up to 2 years. 2 years where you're not producing any product, therefore you're not producing any revenue. In my current role, the company that I work for, Meritech USA, 2.5 years ago, we didn't exist. We took over a facility, and within 8 months, we were manufacturing product and collecting MES traceability data. Now, did we have a full-blown MES? No, we're still in the process of doing some of the supporting processes and reports. but we were able to collect traceability, and we were able to manufacture a product in which we were generating revenue.
Mm-hmm.
Did we make some mistakes in process assumptions and hardware assumptions and software assumptions? Oh yeah, absolutely. But if you take a look at that, that still is a more cost-effective and time-effective model than waiting for a full 2 years to have something that's pretty well fleshed out, which unfortunately, human beings being what they are, even after 2 years, you're going to miss something. So.
Yeah. So I think you touched upon two very important things there. So let's say if you talk about downfield, what I can see is that even if you know that your systems have different data models, they're all point solutions, they're implemented at different times, replacing them right off the bat might not be the best option, even if you know they're not good systems.
That is a matter of opinion.
Yeah.
And I'm going to say that because they might have a system or a process that for the most part they're very comfortable with. There's no pain involved.
Yeah.
So for them it's a good system. The challenge there is using that as a stepping point to find out, well, what can you help them to provide additional value?
Mm-hmm.
Ultimately, it comes down to three things that are important for manufacturing, and we've touched on it already. Equipment uptime, which improves your production capability, your production performance, the trying to get things cycle time through the process as quickly as possible, which influences throughput. And so that tells you exactly how much product you can put out on a daily basis. And then first time quality. And just to emphasize that, you might have excellent equipment uptime and an excellent production performance, but if your first time quality is 50% or less, that's a significant problem, because rework, it doesn't matter which type of rework is, or scrapping, is expensive and time consuming.
Yeah.
So trying to make sure that you're hitting your first time quality is very important.
I like that you say first time quality and not quality. I think it's time to change our metric in terms of what we deem as important.
Mm-hmm.
Yeah. Because if you only look at scrap, let's say, and you don't account for all the time you lost in rework, all the resources that you spent, I think that's not giving you the full picture.
Okay. Yeah, I agree with that.
Yeah. And in terms of, let's say, greenfield, right? So I will give you an example of an implementation that we were doing. Like you said, the requirements from different teams kept on increasing. Something was defined at the start, but then, when you talk to different teams, everybody wants a certain set of functionalities. And in that scenario, the most important thing is to get the line running as soon as possible, to get the minimum viable product, to get the line running. And after that, you can build on, let's say, in a second phase, depending on what the requirements are.
Right. And this kind of goes back to the old project management adage. Scope creep will kill you. This is actually one of the reasons why a lot of MES deployments have failed, is because there was too much scope creep. They were trying to basically provide everything for everybody, and it kept on delaying things. Certain functionalities weren't deployed properly, and it becomes a harder mess. That's one of the things that a more tactical, or almost like an agile type thing, where it's like, we're going to deploy X at this point of time. We're going to make sure that X is operating. Once we're done with X, then we will work on to the next phase. I hope that everybody that is involved in manufacturing realizes, and it doesn't matter if it's just like a simple food item or tires, is manufacturing is a very complicated thing, multi-layered, multifaceted, and being able to get something small and tangible at first is going to be very important. Because if you don't, then you're not really managing things, and the risk of going out into the weeds is very high.
Yeah. I think that approach of, tackling it use case by use case works when, let's say, there is a bottom up need of a software. But I would like to ask you, what if there is a new CTO, CIO, and that person wants to, drive an implementation or a roadmap for digitalization? And in that, let's say, top down scenario, how do you ensure that, all these things are taken care of? What do you think the role of leadership should be?
That is a tough one. Because the one thing that we have to be very careful of to begin with is understanding the technology landscape and how we're using technology to enable the systems. First and foremost, though, is that's always off to the side. It's always an influencer. First and foremost, understanding all the processes that are involved. If you don't understand the processes, you don't know how to implement an enabler, to control it, manage it, et cetera, et cetera. If those processes are not known, stop right there, figure out those processes first. Second thing is understand the pain points. I don't want to say every, with trying to put together, well, I think the plant needs this, when in reality, that's probably plan, third thing. Low-hanging fruit, they need something else at this time. So being able to understand, okay, what are the needs? What are the limitations? What are the outside influences? Even to get into pharmaceuticals, you need to know the legal regulations. But that's just one thing. With regards to automotive safety, there's a number of different regulations involved with that as well. Those are the things that need to be taken, because those are the must-haves. So understanding the must-haves is really, really important. The second thing is understanding the technology. Last few years, we've been moving a little bit more away from understanding and being focused on Industry 3.0 and expanding to maybe even having like something that's kind of SCADA-like, but a little bit maybe a higher up, aggregating the data, so on and so forth. So there's been a little bit more interest and understanding of that. Get the understanding of the whole landscape, and then being able to understand and target what you need to do first. One of the things that we always have to be very cognizant of is, if we're using Microsoft, we know that we have the Microsoft refresh projects every few years. And that will influence not only budgets, but also influences your resources on what tasks they can do, because sometimes they are busy spinning up a new server to replace an old server.
Yeah. That brings me to a very interesting point. What about hosting everything on the cloud and let everything be managed like that?
Okay.
Yeah.
One of the biggest risks that the cloud has, and it's still there even though they've stabilized it very much over the past few years, is you've got an IT operation offsite. So you are dependent on your wide area network to provide that connectivity in real time. Especially in natural disasters, that's a big risk. So typically you might have a server doing some stuff locally and then feeding it up into the cloud.
Yeah.
The other part of it is that if the solution is being provided by a third party, flexibility of that third party meeting your specific process needs is a little bit more difficult. Now, if they've done their homework right, a lot of that should already be built into their system. But if you need to make some sort of change and it's not something that it's going to be a value add for their operation, you may not get that change in a cloud-based system that's provided by a third party.
Yeah. So if as a manufacturer, I want to make a decision as to what processes can I keep on the cloud and what processes should I keep on-prem, what would be your suggestion in terms of what factors they should keep in mind?
Okay.
Yeah.
The current rule of thumb is if you need anything real time and you need to have an immediate response to something, you keep it on premises. If you're doing dashboards and reports and other database activities that do not necessarily need to be linked to real time, that can go out into the cloud as long as some of those reports are not critical to your overall operation.
Because it is all a game of network, right?
It's really down to networking. It's all down to, a lot of stuff like the old, for a while, putting stuff out on the Amazon Web Services and other providers was very, very good. And you were able to configure your systems in such a way that you had server redundancy and everything like that.
Yeah.
So, as I mentioned, those solutions have gotten better, but you're still kind of at a potential risk. So,
yeah, I think that is a good framework to look at it. And because we are on the topic of the past few years in terms of how MES, the space of MES is changing, what do you think about low code, no code platforms? And so I just had a discussion. I think there was a post I made, which, I outlined that it is very important to have your process defined, then have your product assessed in terms of how it can integrate with other systems and what software vendor are you working with. So these are the three things that I outlined. But then I also got a comment in which it does not matter what your process is. Your MES should be so configurable, customizable, that it can fit in with any process. And that is how defines a good MES. What would you say to that?
I'm sorry, that cracks me up. And the reason for that is the diversity in manufacturing, not just in hardware, not just in processes, but you could have two plants literally right next to each other and they do things very differently. To have a one-size-fits-all MES system, it's possible. We're nowhere near that at this point. Because there's so many different iterations and ways of doing things that and we just mentioned it, automotive versus aerospace versus pharmaceutical versus steel and plastics. Steel and plastics is a continuous thing. If the temperatures drop in those manufacturing environments, you've shut down the plant for several hours until you can get back up to the proper temperature, et cetera, et cetera. That complexity is very difficult to put into one MES solution. So being able to have something that for something like automotive or something that is highly traceable, it has a big traceability requirement like aerospace. There are systems out there, solutions, software packages that do a really good job in those industries, in those environments. But they will not do the exact same thing if you get down into pharmaceuticals or food and beverage or some of these other manufacturing type activities.
Yeah.
So to go back to your statement about code versus no code, yes, it would be nice if we could get to a point where it's configurable, that we don't need to bring in a software engineer who can go in and produce and test out code. Not only for the ease of manufacturing plants, but also since we have a global shortage of skilled software, IT, OT, PLC resources right now. The ability to actually put together a project is hard right now to make some of those code changes.
Yeah.
If you're not part of a software provider like a Siemens, like a Rockwell, like an SAP, et cetera, et cetera.
So I think what you're saying is even if that a product wants to be something for an industry, right? You can have an MES for automotive, you can have an MES for pharma, but that is only because iteratively that product has learned, been developed to encapsulate most of the use cases. Because in most manufacturing plants, I mean, it's, let's say in automotive, the ways of working will not be very drastically different. I mean, they will have their nuances, but the only reason why that can be possible is because they have implemented in so many places, or they have experienced so many customers that they improve their product to such a level. Is that correct?
Right. That's a good way to put it. Because, and this should also surprise no one, there's no really common MES standard, manufacturing standards out there. Yeah. So yes, each industry kind of developed their own solutions and their own processes and silos. So it's, again, just to emphasize the point, automotive has no need for the structured reports and traceability data tables that pharma needs. That's not only something that is not a value add to them, that's something that might even be a detriment to them. So, again, it comes down to truly to understand the processes. When I interviewed and got the project management role at pharmaceutical, one of the things they asked me was, how familiar are you with the pharmaceutical industry? And part of what they were looking for is understanding that, yes, I understood the regulations. And those regulations, sometimes they even define, this is what the report will look like. This is what your MES is going to have to produce. So,
yeah. Let's talk about the book. Why should people read it? How can people access it?
Okay.
Yeah.
The book itself, I was very blessed to have the International Society of Automation not only support the development of the book, but they are the publishers of the book. So this book is available globally. I kind of hinted at it before. We took a top-down approach. Chapter 1 talks about manufacturing, MOM, and how MES is different from ERP and PLM. And then we get into a common definition of what constitutes MES. And then we went a little bit further down, and okay, this is how MES is commonly defined, but this is how it impacts every single industry that we've been talking about. And then we were looking at certain trends, and what may be beneficial, in the near future. The book was initially released in April of 2020, which of course I didn't really want it then, but because of COVID. But one of the topics that once that book was released, and then we kind of also circled, there's two topics that came up. One was that our initial impact, we were trying to get a book out just so that here's MES as a common definition. One of the things that we deliberately missed because we were trying to get the book out, and remember what I said about scope creep, we were trying to keep the scope of the book intact, was that we kind of missed a little bit of a more deeper discussion about MES versus MOM. Then also, because we were in the middle of COVID, one of the topics that came up in conversations and promoting the book was more automation. How can we automate the plants? Because a lot of the human factor couldn't be there because of the COVID lockdowns. And that actually, that is an ongoing conversation. That's not going to stop anytime soon. But the point I want to make here is that when we take and put together an MES so that you know exactly what your manufacturing environment is doing in a real time, you're able to provide some trends, you will find opportunities where you can automate things further. Now, Will we ever totally achieve a fully automated plant? I don't think so. And the reason for that is every piece of hardware that we have will eventually break down and fail. How do you repair that? Eventually, we might get machines that are smart enough to do that themselves. Right now, we require humans.
Okay.
Also, all the different influences that directly and indirectly impact manufacturing, your customer service, your supply chain, you're dealing, even regulations, you're dealing with outside human organizations that have a different set of goals and objectives than your manufacturing operation has. And because of that, being able to manage those goals and objectives accordingly, that is a very
human
how best
thing.
to put it.
Yeah.
It's a human thing.
Yeah.
Trying to figure out a way to automate that is going to take an advancement in AI right now that is not available. Okay, so I don't see manufacturing to ever be totally, fully percent automated, but we could eventually get there. At least get to a point where that will happen. And MES is going to be part of that because it will have the data and information to support that.
The lights out factory is not something that will happen any so.
Not the way I can, not with where I'm seeing everything right now. There's so many processes that still need to be defined and being able to put into a system that has to be programmed and configured properly, that there's going to be a lot of step learning curves in order to eventually achieve that.
Yeah. Because if you should leave the very large manufacturers, for most of the cases, their MES currently is paper. From what my experience is.
Yes.
Yeah.
And that kind of goes back to something that we hinted at before, but we really haven't talked about, and that is another reason why certain plants don't want to move to an MES is because they do not understand and they don't see necessarily the value in digitization. So to expand on that idea, some plants, especially some of the small manufacturers, are still doing something that they were doing 30, 40 years ago. They take a piece of paper and they take a clipboard and they go out there and they manually fill out a spreadsheet. And that's how they are able to manage their manufacturing execution and their operations. The problem with that is each piece of paper is isolated data. So it's going to take someone to take those sheets, put it into an Excel spreadsheet, start linking the different parts together, which is a manual process, and then be able to take a look at trends and be able to make predictions if that data is organized properly. Manual.
And also the data discrepancies that caused in this manual transfer.
Right.
So you don't know in the end it is right data or not.
Right. You're dependent on whoever is accessing that data and putting it on the paper. So you got a human factor variance there as well. Now, you add a digitization process where the data is being collected automatically because it's going through the process itself. You got your sensors, timers, et cetera. Then you aggregate that into a database.
Yeah.
Not only is your data collection more stable and quicker, but now you have an ease of automating stored procedures or whatever to generate the intelligence and the information in such a way that it's useful. And if that's done properly, instead of hours or days trying to collect and aggregate the data, you now got it down to minutes, if not seconds. So there's a huge benefit there. And especially if they are generating reports, instead of trying to manually generate a report or doing something manually to that spreadsheet, you now have a system that's generating that. That is a huge value add. That can be a labor time savings.
Yeah. I had a discussion with one of these plant heads, and he said that he wanted his operators to put data in manually so that they have accountability. Can you imagine?
Is that value added work? Is that adding something that the operator's doing to make sure that that product can be produced with high quality and the highest production performance as possible? The answer is no. It is a learning tool, but in so doing, you're negatively impacting your manufacturing environment because you're asking them to do something that is not value add. Their job there is not to write down data on a piece of paper. Their job is to put together a product to ship out eventually.
Yeah, and that doing that activity is probably impacting their actual work, basically.
Yeah.
Yeah. So you talked about AI. What are the main use cases that you can see currently? Is predictive maintenance one thing that is actually very realistic?
Before we go there, I want to address something that if you've not seen it in manufacturing system marketing, you should. And that is the use of certain buzzwords within marketing to get your attention, which may or may not be representative of what's actually going on.
They get my attention for sure.
Yeah. 3 main big buzzwords. This is an industry 4.0, 4.0 solution.
Yeah.
What does that mean? Industry 4.0, like as I said earlier, means nothing more than just IT coming into the manufacturing environment and providing some efficiencies and better ways of doing things by enabling the process. That's all it means. The other term that's linked to Industry 4.0 is the Industrial Internet of Things, IoT.
Yeah.
Initially, all that meant was the devices that had defined data models that could connect up to the network to participate in the Industry 4.0. I've seen something that says this is a IoT solution. What makes it such? Is it tying into a process? Is it tying into a workstation? Is it codifying or collecting several SCADA systems together? What does that mean? If you say it's a IoT solution, unfortunately for me, it means nothing. Okay. The third one, and this is the reason why I did this tangent, is AI. AI is a buzzword right now. And the reason for that, and I'll give a really concrete example. Last week, I had a vendor come in with a solution, and I'm not going to go into any further details of that. They said it's AI. As part of their demo, we, as the team that was there, realized it really wasn't AI. It was just an easier way to configure something so that it could do some pattern recognition on what it was operating on. It wasn't overall data pattern recognition. It definitely wasn't decision making. So it really wasn't AI. Given that, going back to your question, Kunal, currently what I see with AI is at a point where it can basically recognize patterns and data and make recommendations. And in certain cases, those recommendations have been at least partially automated.
Okay.
It is not anywhere near being able to make actual complicated, complex decisions. So I see AI right now still maturing. Eventually getting to a point where we can get to where it will be beneficial to generate some useful intelligence. As you mentioned, predictive maintenance, where it takes a look at maintenance data and able to say, okay, I predict in 6 months this component's going to fail or the sensor's going to fail. That is really useful right now. And that's predictive maintenance has been around as a solution for about, I want to say 6 or 7 years now. So I think that's pretty mature. It still would be up to each manufacturer to see how it would best fit into what their operation is and if it would be of value to them. But that's kind of where I'm seeing AI at this point.
Because the models are, let's say, more matured right now in terms of what is available in the market, do you think manufacturers might not have to have, let's say, 2 years of data to build something actually useful? Do you think that might be a scenario?
That is a scenario. I would definitely, and I'm going to do another quick tangent here. MES, and when we talk about predictive here, it's a buyer's beware market. Do your homework. Find out exactly what it means. Find out what's going on. There are predictive software packages out there that require that historical data. Others have been able to generate and done some, I want to say, process learning so that they can make recommendations based on what they've already aggregated in their own operational past.
Yeah.
So it really would depend on the software being provided in and of itself.
So what do you say to the folks on LinkedIn talking about AI industry 8.0, 9.0, 50.0? How do you look at that?
The way I see it is that we are still firmly in Industry 4.0 because we're still, even though the IT solutions have gotten better and more mature, maybe even a little bit more complicated, it's still Industry 4.0. We're still dealing with servers and software and so on and so forth.
Yes.
Eventually, if we can get the data and the intelligence to that point where we can make decisions, Industry 5.0, I envision to be AI, as in fully blown AI, as in it's able to make complicated, correct decisions to move and operate manufacturing.
And your business again. Yeah.
And your business, because you were talking about business processes earlier. We're dealing with the business as well. That will be Industry 5.0. Are we there yet? No, we're still dealing with AI, dealing with basically properly aggregate data and looking for patterns. I think we are a long ways away from something that's truly artificial intelligence to being able to make complicated decisions in real time.
Yeah, I think that is a very important distinction that many people are maybe confused about. So I think that is a good point.
And that's the reason why we're having this conversation is you need to understand what the terms are and what the nuances of those terms are, whether it's MES, whether it's ERP, whether it's AI. It doesn't matter. Everybody out there should get to the point of understanding that. And one thing, Kunal, we haven't talked about yet, and I want to touch about right now is these LinkedIn forums are a fantastic way, and I give everybody who's participating in them a lot of credit to seek out, ask questions, and get this understanding moving forward.
Yeah.
One of the things I did not talk about the book was one of the visions and goals that I had for the book was being able to have a material, a course book to take to the universities, because right now the universities do not have courses and classes on this area of manufacturing, ERP, PLM, MES, MOM, et cetera, et cetera. It's been difficult to move that forward only because a lot of the accredited programs don't necessarily have room to add this type of material into. So we need to also, as an industry, as these forums, going back to our universities and saying, hey, you are sending us people who are not ready to work in this environment yet because they don't know MES or MOM. Please put together something so that when they get their degree, they're a little bit more familiar with this and they could join us with the feet hitting the ground running.
Yeah, but do you not think that the universities themselves are becoming less and less relevant as the years go on?
No,
Okay.
unfortunately not,
Uh-huh.
because there's a lot of theory and processes that are still covered in them.
Yeah.
They were a lot of the traditional universities, yes, they felt the pain because they were still meeting class, et cetera, et cetera.
Uh-huh.
Every single university that I've talked to has had to go into the virtual meeting model just to survive. Um, with that, that's going to continue. But to be able to take something outside of either an industry or even a simple plant and being able to educate someone on this material, that's still going to take some sort of organization outside of the industry and outside of these plants in order to make that happen.
Yeah, I think you're right in that, because there are a lot of people who message me in terms of, is there a course that I can take on MES or ERP? Is there a book that I can refer to? And for all those folks, the link for the book is in the description. Go check it out. I'm sure that it will help you understand structurally, basically the way you're taught in school. Correct me if I'm wrong, Mr. Seubert.
I'm going to say this, the book takes a common approach to it.
Uh-huh.
Obviously, we can't handle every single use case that's available out there, but I would say that very comfortably, when you complete the book, while you may not understand the technological enablement nuances of MES, you should be able to tell. I should be able to go to 5 people after reading that book and get a similar answer to what MES is.
Yeah, I think that's very, very important. And from LinkedIn, I remember that the way, I mean, we've talked a lot online, but one of the very first posts that I had made, I think that was almost a couple of years back now, and you had made a very long criticism on how the post is not correct, and that is how we started talking. So you were you were mentioning about, the platform gives you an opportunity to talk to people who come from a very different background to you, and basically that's, I think, a fantastic learning opportunity.
Yes, that's, I think, one of the challenges that I have personally is the information's out there. ISA and the International Society of Automation has some really excellent books on manufacturing, MOM, et cetera, et cetera. They're available. We can build classes off of them. It's
Yeah.
not commonly known. And not, especially the last 5 years, traveling to some of these trade shows where they might be able to have a conversation on this and be able to use that as well as social media to get the word out there. It's still a challenge. So everything is still more isolated. And that's one of the challenges that we have. And I think that's another reason why these forums are so important.
Uh-huh. Uh-huh. To end, Mr. Soybert, I would like to ask you, somebody who's starting out in MES, again, this is just, I am trying to help people that, ask me a lot of questions on LinkedIn.
Mm-hmm.
Is MES a good career to be in? I have gotten this question so many times. So I would like to ask you, what is your take on it?
Since I've been involved with manufacturing practically my entire career, um, I want to say that if you find manufacturing fascinating, if it's something that you can get some sort of personal as well as intellectual fulfillment out of, manufacturing is never going to disappear.
Uh,
It will it change? Oh my goodness. What if you would have told me what we were capable of today in 2025 when I started off in 1990, I would have said you're bonkers. Okay. Will it change? Yes, it did. Does that provide challenges? Absolutely. Um, is it something that is needed? Absolutely. No matter what, we are going to need manufacturing. Okay. Can it be frustrating? Absolutely. I've worked 16-hour days as part of my career as a controls engineer. don't really look back upon that with any type of fondness. I'm going to be realistic here.
Yeah.
However, I'm still in it. I'm still enjoying it. I'm still learning stuff. I'm enjoying, because I'm also a scout leader, being able to talk to people like Kunal and other people to say, this is what I know and this is how it can help you. So if you're not sure about it, I would just say it's always going to be dynamic. There's always going to be changes. It's not going to be as cut and dry as banking, but if you like banking, by all means, go into banking. I will never hesitate to say, if you really like banking, go for it. And that's just one example. But if you want to try to enjoy manufacturing, yes, it's going to be there, and you can have a career out of it. Now, IT-wise, have things changed? Yeah, I mean, I've lost count how many different programming languages we've gone through over 30 years. So to take that into account, if you're into projects have gotten better and more dynamic and be easier to be done. So maybe project management's your role.
Yeah, I mean, within manufacturing, also there are so many functions that you can, specialize in.
So,
and the most important point that you mentioned, I think, is that manufacturing is always going to be there.
And I'm going to encourage this. Right now, we are running short. There is a global shortage of IT professionals, OT professionals, and a lot of people who just don't really understand the whole processed concept of manufacturing. There is stability in this industry right now.
So, to anyone listening, that is your cue. Yeah. If you're not in manufacturing, get in manufacturing. Yeah. So with that, Mr. Seubert, thank you so much for having this podcast with me. I will definitely have you again, because there is just so much that hasn't been covered, and I don't think one podcast will do it. But I want you to maybe give me your feedback in terms of how your experience was, and ask the folks to kind of subscribe to my channel so that we can grow.
Yes, I'm going to say this. Kunal has a lot of knowledge and intelligence in this area right now. He led this conversation very well. And I would definitely include that if you do have any future questions in any of the forums that Kunal and I are in, please drop us a line. We do want to help you out. We want you to understand what's going on. We want to get rid of this confusion mud that's been driving this industry for way too long.
Thank you so much, Mr. Seubert. Hope to have you soon on the Messy One Days podcast. Thank you.
Goodbye, everyone.